Good day, everyone. I trust we are all good. In the previous video, we looked at solutions to question 10. In this video, we'll be looking at solutions to the final question, question 11 of Maths Paper 1, May, June 2024. All right, let's get to it. Question 11.1. Two events A and B are such that the probability of A equals 0.4, the probability of A or B equals 0.52. A and B are mutually exclusive. Calculate the probability of B. Here, to calculate the probability of B, we would have to use the formula for the probability of A or B, and this can be gotten from your formula paper. So just turn to the back of your question paper and you can see this formula there. So the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Now let's see each of those. So the probability of A or B has been given to us here and is 0.52. The probability of A is also given to us, it's 0.4. We don't have the probability of B. That is what we are looking for. And here they told us that the two events are mutually exclusive. So if the two events are mutually exclusive, it means the probability of A and B would be equal to 0. Let's substitute each of those. So here we would see that the probability of A or B is 0.52, and that will be equal to the probability of A, which is 0.4, plus the probability of B, which is the unknown that we are looking for, minus 0, since there is no intersection between events A and B. Now, let's solve them finally. So the probability of B, if we make the probability of B the subject here, if we take this 0.4 to the other side, then we have 0.52 minus 0.4. That means the probability of event B happening will be 0.12. Now, let's solve question 11.2.1. Question 11.2. The items that Elena bought at a tuck shop were recorded over a period of time. The probability of Elena buying a sandwich S, a chocolate C, and a juice J are shown in the Venn diagram. The first question, 11.2.1, is what is the probability that Elena will buy a sandwich? So the probability that Elena will buy a sandwich would be, so we can just write this formula. It will be the probability of sandwich only, which is this 0.09, plus the probability of buying a sandwich and chocolate only. So the probability of buying those two only, then plus the probability of buying a sandwich and juice only. Then plus the probability of buying the three items, which is 0.01. So the probability that Elena will buy chocolate and sandwich only is 0.02. The probability that Elena will buy sandwich and juice only is 0.04. So we add all those together. So that will be 0.09 plus 0.02 plus 0.04, then plus 0.01, and that will give us 0.16. If we multiply that by 100, that will give us 16%. You can report the answer as 0.16 or 16%. Question 11.2.2. Calculate the probability that Elena will buy at least two of the three items. So the probability that the learner will buy 2 of the 3 items will be the probability of buying chocolate and juice only, which is 0.03. The probability that the learner will buy juice and sandwich only, 0.04. The probability that the learner would buy chocolate and sandwich only, and that will be 0.02, plus the probability that the learner would buy a sandwich, chocolate, and juice. And the probability that the learner will buy the 3 of those items will be 0.01. So we had all those together to give us the probability that the learner would buy at least 2 items. So I've already explained this. So we had all those together, and that will give us an answer of 0.10. If you multiply that by 100, that will be 10%. Now, 11.2.3. Calculate the probability that the learner would not buy any of the 3 items. So what we can do is to add all this probability together and take them away from 1. And that would give us the probability that the learner would not buy any of the 3 items. So let's calculate all this. Every of these probability represent the probability that the learner would buy at least 1 item. So we add all those together. So to calculate the probability that the learner would not buy any of the items, then we solve this. So we have to take this value away from 1. So we take that away from 1, and that will result in 1 minus 0.43. So we have 0.57. We can convert that to percentage by multiplying by 100. So that gives us 57%. Question 11.3. 7 guitar players, each with a different name, participate in a concert. In how many different ways can the names of the guitar players be listed, one below the other in the program? So if we are dealing with 7 guitar players and you want to arrange them, if there are no restrictions, then the number of ways you can arrange 7 individuals will be 7 factorial. So 7 factorial on your calculator, if you look at your calculator, the factorial sign is here on a Casio calculator. If you are using Sharp, it will also be on your calculator as well. So it's up here. So you just have to punch the number 7. Then we want the factorial. Then we press Shift. Then we press this factorial sign and we press equal to. So 7 factorial is 5,040 ways. So those are the numbers of ways you can arrange 7 individuals. In this case, the 7 guitar players without restriction. Now, question 11.3.2. After the performance, the guitar players wait backstage. There is a bench with only room for 4 to sit on. What will be the probability that the 4 guitar players will be sitting in alphabetical order from left to right? Now, in order to solve this question, there are 4 individual guitar players that sit backstage at the end of the concert, and they must be seated in alphabetical order. So if they all have different names and they are seated in alphabetical order, that means you can only have one seating arrangement when you talk of alphabetical arrangement. However, you must also think of the possible ways you can arrange the 4 of them, right? You must, if you don't have restriction and you want to arrange 4 people, so that will be 4 factorial. You can arrange 4 people in 4 factorial ways if there are no restriction. So this is A, B, C, D, right? The four of them, and they have different names. That is, yeah, if you want to arrange them in alphabetical order, it will only be one possibility. But you have to look at if I don't have any restriction, if I can arrange them randomly, then it means I can arrange them in 4 factorial ways. And if you look at 4 factorial will be equal to 24. 4 factorial is the same as 4 times 3 times 2 times 1. And if you want to use your calculator, you can punch it into your calculator, 4, then shift, then factorial. So that gives you a value of 24. So you can arrange 4 people, 4 individuals, the 4 guitar players in 24 ways without any restriction. However, there is a clause in that question that those players must be arranged alphabetically. So if you want to arrange people alphabetically, and they have distinct name, it means that they can only be arranged in a single way. So it means that you will have one possibility out of a total of 24 events, right? So it means that the probability of arranging the 4 guitar players alphabetically will be 1/24. Question 11.3.3, the last question. During the performance, the 7 guitar players sit in a line on a stage. 4 guitar players are female and 3 are male. In how many different ways can they be seated if the males may not sit next to each other? All right, let's look at a pictorial representation of that scenario, right? So we have 4 females out of 7 guitar players, which means, and according to the question, we have 3 males. And the male must not be seated next to each other. It means that the males were inserted in between the females, right? So here, you can have a male here, you can have a male here, you can have a male here. Then, yeah, you can have 3 males provided they are not sitting next to each other. So the 3 males were sandwiched between the females. Now, what we can do here, based on this representation, and this representation will go a long way to help us to solve this question. We can look at the number of ways these 4 females can be arranged. We have 4 females, right? They can be arranged in 4 factorial ways. We have seen 4 factorials before. So 4 factorial will be equal to 24. So these females can be arranged in 24 ways. Now, let's look at the sitting arrangement of the males, right? There are 3 males, right? And those 3 males have the possibility of being fixed in any of these 5 positions. So we have to look for a way we can arrange 3 people, 3 males, in 5 possible positions, right? So we are looking for 3 positions out of 5 total possible positions. So this is a simple way we can do it. So if you are looking for 3 out of 5 positions, then this is how you can solve that easily. So it will be 5 factorial, the number of total possible spaces, divided by the number of individuals you have. In this case, that will be 3 individuals. So that will be 3 factorial, then bracket 5 minus 3, and you do the factorial as well. So in this case, you have 5 factorial divided by 3 factorial times 2 factorial. So that is what you have here. And if you simplify this, you will have 10 possible ways. Now, once you have arranged the 3 males in 10 possible ways, here in these 5 spaces that are open, then you will have to look for a way. It's also possible for you to arrange those 3 males after you have chosen the 3 positions from this 5 positions. It's also possible for you to arrange those 3 males in 3 factorial ways. So that is what we see here. So you arrange them in 3 factorial ways, and 3 factorial will be 3 times 2 times 1. That will be 6 ways. So we have looked at 3 scenarios now. We have looked at the possible arrangement of these females, and that will be 24 ways. We have looked at how you can arrange 3 boys in 5 possible spaces, and those are 10 ways. And after you have fixed those 3 boys in those 3 spaces, it's also possible you randomize their sitting position in 3 factorial ways, which will be 6 ways. Then it means the total number of possible ways you can arrange those 3 boys in such a way that they are not sitting next to each other. The total number of ways will be 24 multiplied by 10, then multiplied by 6. And that will give us a value of 1,440 ways. And that brings us to the end of paper 1, Met of May-June 2024. Congratulations if you have stayed with us till the end of this video. This brings us to the end of Met paper 1 of May-June 2024, the last Met paper 1 that was written. And I've checked on the internet. I've not seen any solution from the Department of Education. I've not seen the solution on any YouTube channel. So to my knowledge, this will be the first video of the solutions to Met paper 1. And I'm doing this not to take credit for the first person to release the solution, but I know that your examination is fast approaching. Thus, the reason to release the solution so that you can go through the solution and better prepare yourself for the forthcoming exam. Next, we will be looking at solutions to Met paper 2 of May-June 2024, and we'll be looking at solutions to physical sciences as well. Physical sciences papers 1 and 2 for May-June of 2024. So if you want to be among the first to receive the notification for those videos when they come out, please kindly subscribe to this channel and help this channel to grow by sharing this video and liking this video, so you can share it with as many friends as possible. Those that you know, your friends at school that want to write the forthcoming matric examination, share this with them quickly so that they can go through the solution and they can better prepare themselves for the examination. And I wish every one of you the very best in your examination, and you must stay blessed. Bye. Bye.